Hello and welcome back to Elementary Algebra. We are going to talk about 6.4 special factoring, which are those formulas we learned in chapter 5, except now we are doing the whole process backwards. So one of the formulas we learned last time is that if you have a minus b times a plus b, you would get a squared minus b squared. So that was something that we did last time, and that was chapter 5. For us, this formula now will be flipped. It's going to be called difference of squares. And it's going to take a situation when you have a squared minus b squared and break it down into a minus b, a plus b. So as you can see, it is absolutely the same formula, except this time around, this formula is used completely backwards. So the way we use this is, let's say you have x squared minus 36. You recognize 36 as 6 squared. Oops. And now all you need to do is write x minus 6x plus 6. You're done. You don't need this step per se, but most of the students like it because it is helping them visually see that x and that 6 that are parts of these two parentheses. There are no calculations here, as you can see, so you either know the formula or you don't. And the method that we used earlier, with the breaking the chart and all of that stuff, it does work, but it's very difficult to see it. So here we go. 100 minus y squared. Well, 100 can be written as 10 minus y squared, and that's 10 minus y, 10 plus y. It's that quick. Your job is to figure out what these factors are by looking at the square roots of the numbers that are given to you. And you generally recognize this one because you always have what we call perfect squares, which are the numbers like 1, 4, 9, 16, 25, 36. Like all of those numbers are 1 squared, 2 squared, 3 squared. So knowing those numbers definitely helps a lot. If you don't know that 144 is equal to 12 times 12, then it kind of makes it a little bit harder to work out the problem and separate these things. You can also have something like, let's say, x squared minus y squared, in which case you have no numbers. All you need to do is to write x minus y and x plus y, which is technically the same as the formula you have up there, except this formula is one is written in as a and b, and the other one is written as x and a y. It's the same thing. So to be successful in these formulas, you need to know this perfect square table. So 1 times 1 is equal to 1, which means that the square root of 1 squared, there we go, square root of 1 is 1. 2 times 2 is 2 squared, which is 4, and the square root of 4 is 2. 3 times 3 is 3 squared, which is 9. Square root of 9 is 3. 4 times 4 is 4 squared, which is 16, which is the square root of 16, which is 4. And you can go down this list. You can create these if you care, obviously, right? You can create this on your own, uh, the whole list, and find out the numbers like 196, 121, square root of 81, right? It's 9, and the meaning of that is simply that, when it's the opposite operation from squaring, because now we are taking technically square roots. That's the square root of 100 is 10, and that's how I know that I'm supposed to put 10 square in there. So the little bit more, I would say, a little bit more interesting cases here would be when you have, let's say, 25x squared minus, let's say, 16. Now, in this case, right, you have 5x squared minus 4 squared. So these are a little bit trickier cases, I guess, to see. But again, the more you practice, the better it gets. And knowing the square numbers, right, as 4 squared is 16, and all of those. So let's say you also have like 49x squared minus 64 y to the fourth, for instance. So this would be considered as something much more involved, obviously, because now we are also having this knowledge that y squared times y squared is y to the fourth. So technically, every time when we do these things, it gives us opportunity to calculate not just numbers but also with variables when these values are not just squares. So this is again 7x and then everything squared. Why? Well, 7 squared is 49 and then x squared is x squared. So that's something that we can quickly get. Minus, and then you have a 64, which is the square root of that is 8. So you have the 8 and then the y squared, everything squared. Again, why is that so? Because 8 squared is 64, and then if you remember, y square square is going to be y to the 4, which is exactly what we have. So now, when you look at these here, it's quickly 7x minus 8y squared. I have room. 7x minus 8y squared times 7x plus 8y squared. So we are just using the formula. We really don't have a lot of calculations here. Technically, all we are doing is we are figuring out what are the values of these square roots to break the numbers and to break the, and then later if you have a fourth or something like that, to break the variable as well. So let's take a look at some of these from the textbook, and then we still have the other two formulas that we had in the previous class. So let's see, I mean in chapter 5. So let's go and see what could be. So try this one. 36m squared minus 25n squared. Let's see what you get there. If anyone is done, just, say what you have.
I have 6x plus 5 and 6x minus 5.
6
M
minus
5
5
m
n.
plus 5.
Yes, okay, good. So we just have to use the variables that are there. Great, that's it. Right, 6 times 6 is 36 and 5 times 5 is 25, so awesome. All right, one more, and let's go with the next. So one more from the book. This is problem 31. 81 r squared minus 49 t squared. Anyone?
Is it 9r minus 7 and 9r plus 7?
9r minus 7t.
Oh,
Right?
okay.
T.
Yeah.
And then 9r plus 7t. Good. So that was just that one little part there that we have to have the variable. I mean, it's not a little part, but it's, we have to have those variables. But yeah, that's it. You got the numbers and you got the form. Good. Now, if you have, let's say, 25x squared plus y squared, that's equal, we can just cry, right? Cannot factor over real numbers. So I'm going to just connect this cannot factor with the positive sign over there, so you know exactly why you can't do it. The formula says minus, and if you run into a problem that has a positive in there, well, can't do it, right? Can't do it. So that's what we have. Now, some of these problems will again have the GCF with it. Now, you technically don't need to do GCF in this case, but you can. See, the problem is that your homework, right, in my MATLAB will say factor completely. Your exams and final exam will say factor completely. And it's much easier to always do GCF first and then worry about the rest of the factoring than to do the other factoring with larger numbers and everything else and then miss possibly the GCF at the end. So what I'm going to do here is I'm going to start with this problem with without GCF. So I'm going to solve it as 2x minus 10, 2x plus 10. And you might walk away. Now, the issue is if you walk away is that you didn't factor all the way, because you can pull 2 from here and you can pull 2 from here. And 2 times 2 is 4, right? So apparently there is 4 that we can factor. But if you see that GCF here and you factor out 4, you get your x squared minus 25, which is x minus 5, x plus 5. And this one is now factored completely, right? It's factored completely. You have 3 factors, where the one on the top, as you can see, is incomplete, so you lose like, I don't know, 2-3 points, whatever is there in the solution key for, let's say, final exam. Or my MATLAB, this step is correct, but it's incomplete. So my MATLAB is not going to tell you, oh, great job, or something like that. It will flag you and say, okay, but you can still go on and factor more and do more work. So if you want to now do these things right up there, then you would have to pull 2 out, get x minus 5, pull another 2 out over here, get x plus 5, and then 2 times 2 is equal to 4, x minus 5, x plus 5. It's not impossible, right? We still get the same problem, same answer, I mean. But the problem is that you might miss it, right? You might miss it. And then you might miss those points for the problem. So when you are able to do the GCF, right? Pull out the value and see what is left over there. So that is what we have for this particular factoring. And now we have the other two. We only have 2 minutes. Well, we'll have to push that for the next class, because we can't do this in 2 minutes, or now it's less than 2 minutes. All right, so well, now that we only have that much, I'm just going to write one more real quick problem. So a squared b to the 4th minus 36c squared. So when you have a problem like this, you say, oh, all of the exponents are getting cut in half, and all of these numbers would take the square roots. So ab squared minus 6c squared. Again, every exponent is cut in half, and every number, like 36, the coefficient, is taking the square root. So all I need to do now is to write ab squared minus 6c, and then ab squared plus 6c, and that ends that problem. And again, for one more time, if you want to check these problems, all you need to do is to FOIL back, and you have to get original problem. So when you multiply these, you do get that one, and then the middle terms will cancel, right? And then you will have your value. So that's that. There will be a part 2. So next class we're going to finish the other 2 formulas that we didn't get to do this time, and then do the other section that we have. So we should be done with the material on Tuesday. I will see you then. Bye.
Thank you.